Hi, in this video, we are going to look at a few problems from differential calculus. And we start off with this series summation. So we have to sum the series tan inverse root 3 by 9 plus tan inverse root 3 by 19 plus tan inverse root 3 by 33 plus tan inverse root 3 by 51 and so on. And this goes on to infinite terms. So let's think about how we do this summation. So usually when you have an infinite series with inverse tans, it is most of the time going to be with method of differences, and you want to express each tan term as a difference of two different terms. However, before we can do that, we have to figure out the pattern between these numbers here. 9, 19, 33, 51, and so on, right? So if I have a sequence like this, 9, 19, 33, 51, and so on, I want to find a pattern for it in terms of as a function of n, where n is an integer, right? So the usual way to think of these patterns is to figure out what kind of behavior it will have. Is it a quadratic function of n, or whether it is a linear function of n? So if you take the differences, the difference is 10, 14, 18, and so on. So the difference of these terms is going to be an AP. The difference is an AP, right? If the difference is an AP, you can see 10, 14, 18 is an AP. So then the differences are linear in n, right? Any AP can be written as a term of an AP can be written as an plus b, right? So it's a linear expression in n. If the difference is an AP, then the terms must be not linear, the terms must be quadratic in n. Only if the terms of the series are a quadratic will the difference be an AP. So now what I will do is I'll try to find that quadratic. So let's say the terms of the AP are an squared plus bn plus c. And now I have data where I have n is equal to 1 implies t1 is 9. N is equal to 2 implies t2 is 19. N is equal to 3 implies t3 is 33, and I also have n is equal to 4. But these three things together are enough for us to solve for a, b, and c. So what I will do is write the equations. A plus b plus c is equal to 9. 4a plus 2b plus c is equal to 19. And 9a plus 3b plus c is equal to 33. Solving these equations is straightforward, and you will be able to show that a is equal to 2, b is equal to 4, c is equal to 3. So the series for us becomes 2n squared plus 4n plus 3, starting from n is equal to 1. So therefore, the terms can be written like this: summation n goes from 1 to infinity tan inverse of root 3 by 2n squared plus 4n plus 3, right? Now we will adjust this a little bit and you will see why. So if you think of 2n squared plus 4n plus 3, that can be written as 2n squared plus 4n plus 2 plus 1. So this is 2 times n squared plus 2n plus 1 plus 1. This is 2 times n plus 1 whole squared plus 1, right? So the terms of the series are also can be written like this: root 3 by 2 times n plus 1 whole square plus 1, right? And this starts from n is equal to 1, goes on till infinity. Now, since the term is n plus 1 whole square, we can take a substitution. Z is equal to n plus 1. And basically our Z starts from 2 and goes on till infinity. And we have tan inverse root 3 by 1 plus 2z square, right? I'm just making it look simpler. Once I have this situation, now I'll think of how to split this, okay? So we have summation Z goes from 2 to infinity tan inverse root 3 by 2z square plus 1. And now I can write this as tan inverse 2 root 3 by multiply by 2 here also. So 4z square plus 2. And now I can do this. I can write that 4z square plus 2 as 1 plus, but actually 3 plus, this can be written as 4z square minus 1 plus 3, right? And this is 2 root 3 here. So tan inverse this thing. And why is this better for us? Because we can write it as 2 root 3 by 3 plus 2z minus 1 times 2z plus 1. And this is a tan inverse, right? Now, this is root 3 square. So you should realize that I can make the top part, I can divide up and down by basically 3, and I can write it as tan inverse 2 by root 3, and here I'll get 1 plus, I have divided by 3 numerator and denominator. When I divide by 3 here, I will split it as a root 3 and a root 3 here. So I can write it as 2z minus 1 by root 3 multiplied by 2z plus 1 by root 3. Notice that all I am doing is dividing by 3 up and down. The reason I want to do it like this is because now the difference of these two terms is equal to 2 by root 3, which is the numerator. So I can write it as 2z plus 1 by root 3 minus 2z minus 1 by root 3 divided by 1 plus 2z plus 1 by root 3 multiplied by 2z minus 1 by root 3. And now this is in the proper form, and we can write it now as tan inverse of 2z plus 1 by root 3 minus tan inverse of 2z minus 1 by root 3. So finally, I have expressed my general term as a difference of two inverse tans, right? And once we do that, the summation is pretty straightforward. We have to do the summation of this from z goes from 2 to infinity of this expression. So when I put 2, I get 2 into 2 plus 1. So this term will get cancelled from the first term. This term will remain. This is the minus tan inverse 2 into 2 minus 1. So that is 3 by root 3. So minus tan inverse root 3 will remain. And this term gets cancelled when you expand it out. And the higher term here will remain. When z tends to infinity, this becomes tan inverse infinity. So this is basic technique of telescoping series. The higher term remains when z tends to infinity, and the lower term remains when you take the first value, z is equal to 2. And you are getting basically pi by 2 minus pi by 3, and the answer is pi by 6. So the sum of the series is pi by 6. And I hope you understood the steps involved and how I figured out the pattern in the denominator. So when the pattern is not clear, you should write the sequence of numbers, try to think of the differences, look at the difference and realize whether the difference is linear or quadratic. If the difference itself was quadratic, the terms of the original series would have been a cubic, right? However, it was linear in our case, and we got the simplification after that. Right. So this was the first problem. Let's look at another one. So problem number 96. Let's try this one. And this question says, if limit of n tends to infinity 2023 to the power 2024 whole to the power n plus 2024 to the power 2023 whole to the power n, and the whole expression is raised to the power 1 more n, is equal to L, then find the remainder when L is divided by 15. L is divided by 15. So basically our first job is to find out this limit, right? So usually when you have 1 by n power on top and n tends to infinity, you have something like infinity to the power 0. The way to figure this out, I have this limit that I know, limit n tends to infinity 1 plus f of x power g of x, where or x tends to infinity or something. So the standard limit that we are aware of is this limit x tends to a 1 plus fx power g of x, where fx tends to 0 and gx tends to infinity as x tends to a. So this is the standard limit that we know, and this will be written as e power limit x tends to a fx times gx. This is theory that you should be aware of. So we are going to try to use that concept here, but this is a slightly more trickier situation. So first of all, I want to compare the two numbers here. I want to find out which number is bigger, because my idea is to divide by the bigger number in order to get a 1 inside the bracket, right? So my first job is trying to figure out 2 in 2023 to the power 2024, whether it is greater, smaller than 2024 to the power 2023. Once we figure that out, then only we can proceed here, right? So how do I figure that out? So this is a standard problem. If you take f of x as x to the power 1 by x and find f dash x, f dash x comes out as, by logarithmic differentiation, you should take log of f of x first. Log of f of x is 1 by x log of x, and then differentiate it. You will get 1 by f of x into f dash x is equal to minus 1 by x square log x plus 1 by x square. So you are getting 1 by x square, 1 minus log x here is 1 by f of x, f dash x. This f dash x will be positive if 1 minus log x is greater than 0, which means x should be less than e. So f dash x is positive if x is less than e, and f dash x is negative if x is greater than e. So now in our question, the numbers are x can be 2024 and x can be 2023. So we know that f dash x is negative for both. So that means f of x is decreasing function in that region. F of x is decreasing near 2023, right? Because it is much greater than e. So therefore, I know that f of 2023 will be bigger than f of 2024. So that means 2023 to the power 1 by 2023 is greater than 2024 to the power 1 by 2024. And if you raise, because it's a decreasing function, if you raise both sides to the power 2024 into 2023, you will be able to show that 2023 to the power 2024 will be greater than 2024 to the power 2023. So that is a conclusion based on the increasing or decreasing behavior of f of x is equal to x power 1 by x, right? So now that we know that, now we can think about how to simplify this limit. So I know that 2023 raised to the power 2024 is the bigger number, right? And my limit was L is equal to limit n tends to infinity. I had 2023 to the power 2024 to the power n plus 2024 to the power 2023 whole to the power n and whole to the power 1 by n. So now the bigger number I know is this one. So I want to take it out of the bracket. So if I take it out of the bracket, I will get something like this out of the bracket, but then that means I will have to put a 1 by n power, right? When it comes out of the bracket, it will n and n will get cancelled and you'll just get this much, right? So you'll have this and you'll have 1 plus 2024 to the power 2023 divided by 2023 to the power 2024 whole to the power n inside, and you have 1 by n like this, right? And there is limit n tends to infinity outside, right? So now notice that this part is a constant. So L is equal to 2023 to the power 2024. And now I have to take the limit of n tends to infinity of the stuff that is inside. 1 plus, this is 2024 to the power 2023 divided by 2023 to the power 2024 whole to the power n, and whole raised to 1 over n. Now, if you think about it, this number is a fraction. This is less than 1. So when you raise it to infinity power, this tends to 0, right? This part tends to 0. You have 1 plus something tending to 0 being raised to the power 0, right? So it is obvious that the limit here, this whole limit, will be tending to 1 power 0, which will be tending to 1, right? So this whole limit is 1, and your answer for L is simply the constant that we had pulled out here. L is simply 2023 to the power 2024, right? But our problem is not done yet. We need to find the remainder when we divide this expression, this number, by 15. So L is 2023 to the power 2024, and I have to find L mod 15, or basically remainder when L is divided by 15. L is divided by 15. Okay, so let's think about it. How do we do that, right? So, right. So what happens when you divide 2023 mod 15? When you do the mod 15 of 2023, you will realize that it is congruent to minus 2 mod 15. Basically, 2025 is divisible by 15. It is divisible by 3 and it is divisible by 5. So 2023 is minus 2 mod 15. So by basic properties of numbers, theory of numbers, you know that 2023 mod 15 is this. Therefore, 2023 to the power 2024 mod 15 is going to be congruent to minus 2 to the power 2024 mod 15. And now that is the same as 2 power 2024 mod 15. And we can write that as 2024 is divisible by 4. So this is 2 power 4 times 2 power 506 mod 15, right? Now 2 power 4, if you think of 2 power 4 is equal to 16, and mod 15, 2 power 4 is basically equal to 1 mod 15. 16 when you divide by 15 is going to be giving us 1 remainder, right? So this part contributes a 1 when you do mod 15. So now we just have to worry about 2 power 506. 2 power 506 mod 15, right? Okay. So actually, we don't have to worry about that because we don't have to write it like this. If you think about it, it is 2 power 4 power 506. It is not 2 power 4 into 2 power 506, right? So this was mod 15, and we know that 2 power 4 itself is 1 mod 15. So this is congruent to 1 power 506 mod 15, which is equal to 1. So basically, you should get a remainder of 1. If you are unaware of this modulus arithmetic, you need to do a little bit of number theory. This has been covered in my Udemy course on number theory, basic number theory. You can check out the links in the video description. I have several Olympiad courses, and in your basic number theory course, I have covered all this in great detail. So that should help you figure out the solution for this one. Now, one last problem that I want to talk about is problem 97. And this question says, if y is equal to x power n minus 1 ln x satisfies the differential equation, x square d square y by dx square plus f of n times x dy by dx plus g of n times y is equal to 0, where f of n and g of n are functions of n. Functions of n. Now we have to find out basically the functions g of n and f of n. Our job is to find these two functions. And we are given that this function x power n minus 1 ln x satisfies the differential equation, right? So what I will do is I will use the notation y stands for the f of x, y dash stands for f dash x, and y double dash stands for f double dash x, or the double derivative, and this is a single derivative. So now here you have y is equal to x power n minus 1 ln x. Now if I do y dash here, y dash will be equal to x power n minus 1 into 1 by x plus n minus 1 x power n minus 2 ln x, right? So I'm getting y dash is equal to this expression. So implies if you multiply both sides of this equation by x, I get xy dash is equal to x power n minus 1 plus n minus 1 into x power n minus 1 ln x, right? So if you think about it, I've multiplied both sides of this equation here by x and I'm getting this expression, right? Now, keep in mind that our y was x power n minus 1 ln x. So here, this part is simply y. So I can write this as xy dash is equal to x power n minus 1 plus n minus 1 into y. So this becomes our new equation that we'll start working with, right? So I will write that here. We have xy dash is equal to x power n minus 1 plus n minus 1 into y. And now I will differentiate this again. So I get x y double dash plus y dash is equal to n minus 1 x power n minus 2 plus n minus 1 y dash, right? And if you remember, uh, this expression, I had already found out my relation here. I had written earlier x y dash was equal to, so from this relation itself, I can say what is x power n minus 1, right? So I can say x power n minus 1 is xy dash minus n minus 1y, right? So keep that in mind. What I will do here is I will multiply both sides of this, multiply by x, both sides of this relation. So I'll get x square y double dash plus x y dash is equal to n minus 1 x power n minus 1 plus n minus 1 x y dash, right? Okay. So now what I will do here is take n minus 1 common from the right hand side, and I have x power n minus 1 plus xy dash here, right? So this x power n minus 1 I will replace from here, and I will write it as n minus 1. Instead of x power n minus 1, I will write xy dash minus n minus 1y plus xy dash, right? So I'm getting now n minus 1 multiplied by 2xy dash minus n minus 1 into y, right? And the left hand side is untouched, right? So if you now combine everything, I'll write it on the next screen. I get x square y double dash plus xy dash is equal to 2n minus 1 xy dash minus n minus 1 whole square y, right? Now bring everything to one side, x square y double dash plus xy dash 1, and I do minus 2n plus 2, that is after combining this term and this term, plus n minus 1 whole square y is equal to 0. So notice we are getting x square y double dash plus xy dash 3 minus 2n plus n minus 1 whole square y equals 0. And now this is in the form that we need. We have x square d square y by dx square plus x 3 minus 2n into dy by dx plus n minus 1 whole square into y is equal to 0. So therefore, this function becomes my f of n, which is equal to 3 minus 2n. And this function becomes my g of n, which is equal to n minus 1 whole square. So this is a fairly straightforward problem, but you need to be careful while you do all the steps so that you don't make any mistake while simplifying the function and the derivatives, right? So here we were given the differential equation and we have to figure out what the function looks like. So I hope you have understood what we are doing and how we have gotten the solution here. So I wanted to show you these three problems. In the next video, we'll look at problems 98, 99, and 100. So the next few videos in this series will cover basically JEE advanced problems, and I will be focusing on calculus a little more in the next few videos. So stay tuned for more. And if you like the video, please share the video with your friends and subscribe to the channel. And I'll see you next time.